Can you see it, right?
Yes.
So, yeah, my name is Pablo Postigo. I am professor of optics at the Institute of Optics at the University of Rochester in the state of New York in the USA. Before, I worked in Spain, in Madrid, at the CSIC, doing research for the Spanish government for the last 20 years. So my position actually started like 3 years ago. So let me just tell you some words about, before I go to the topic of the use of AI in nanophotonics. Let me introduce a bit the place where I am now. The University of Rochester is at the city of Rochester, which is in the north of the USA, close actually to Canada, in the Lake Ontario rim. And one of the main issues of this place is that it's plenty of photonics and optics companies. The Institute of Optics was the first institute about optics in the US, was created in 1929. So in about 4 years, it will be the 100th anniversary. And it's probably the first institute of optics in the world. So there's a lot of tradition about optics and photonics in this area, and there are many companies. Some of them you can see the logos there, working in optics and photonics in this area. Concerning what I do, I started my career doing research on 3-5 semiconductors and integrated photonics. So there's some, I would say, many companies around that do that. Probably the most well-known could be AIM Photonics. See the logo over there. AIM Photonics does a lot of integrated optics on silicon. And they have a nice facility for integrated photonics on silicon wafers. So we collaborate with them and with other companies, and I think well, if you have any questions about all of this, I'll be happy to answer to you. The institute is devoted to optics, photonics, and bio-optics and biophotonic engineering. So there's a lot of research also on how to use photonics for medical and biomedical applications. Now, well, this is just, probably you all know what is nanotechnology, and sure you know about AI. So I'm not going to tell you about this. We are living a moment where AI seems like it has a big hype or explosion around all of these topics, but it is. I mean, it is true that this started to happen many years ago. I remember when I did my postdoc at MIT a long time ago, almost 30 years ago. We fabricated chips with the first neural networks, and they were photonic chips. So AI and neural networks have been there for a long time, but now it is true that we are having all the technologies that allow us to use AI in a much, let's say, easier and effective way. So that's why we are using AI in many fields, of course, in general in nanotechnology. And the main reason of that is because AI helps to design and discover new nanomaterials by predicting properties or optimizing those materials. So at the end, what AI allows is to probably reduce the need for time-consuming or expensive tasks that may happen when you test or when you design devices. And that comes with a cost, which is that you need time to actually train those networks, and you need computer resources for all of that. Sometimes you can borrow those computer resources. There are many companies offering that. Other times you can use a supercomputer or probably a small computer for many other tasks. But it definitely needs of time and resources. And there's always a question about if the final result is going to compensate you for that for those expenditures, let's say. So how we use this for nanophotonics, which is my research field, right? Actually, I mentioned the MIT. So when I was back to Spain, I started a research line on nanophotonics for fabrication of photonic crystals and explore new properties by using this mix of photonics and nanotechnology. So what I wanted to do is apply to use nanotechnology for all of these devices that were previously made in the 70s, right? And indeed, all of that offer new possibilities for devices like microlasers, things like that. Here in the right panel, you see one of our photonic crystal lasers that demonstrated room temperature operation for the first time using quantum dots. So indeed, nanophotonics work, and there could be there are a lot of applications using that. Today, we are focused more on using nanophotonics for quantum. Quantum, again, is one of the things that is a big hype today. So quantum photonics is a big topic. Even quantum computing, quantum optical communication, quantum optical sensing, and but you could use it for many other things. So about this. Now, as I said, how AI is helping us for all of this. Well, AI has two important words, I would say. It can optimize and it can predict. So we are using it for optimizing the design and fabrication of nanophotonic structures. And we are using it for predict some properties and optical properties that we want to achieve using our nanomaterials. All of this give us some new results and some new discoveries, and I will just mention three of them related to this. One about some nanostructures for quantum photonics, then about some use of AI for actually enhance the response of an optical of a photonic device to obtain a better signal, because sometimes especially when you do quantum or you do biosensing with optical devices, your signal can be super small, plenty of noise, and to have something that extracts your small signal from that noise, it could be really useful, and AI can do that. And a last application about prediction of new material using nanostructures, which is just optical filters, which are made by stacking layers with a nanometer thickness. So as the first example, the use of AI for quantum photonics, well, I don't want to go to details here, but let's say that when you have something super complicated to simulate or to design, that you want to go on an integrated chip with some quantum optical properties, state-of-the-art thing, you may face that you need to optimize a lot of different parameters, a lot of them. Here I am showing this slide where this structure is a microstructure, actually has a lot of these small things, small teeth there you can see. And all of these are at a distance of that central region, like in a slotted region in the center. And we have to optimize many of these. If we do that by using traditional procedures, that may take a very long time and sometimes even impossible to do it on a specific time. So that's where it is worth to use AI. You can train a network to optimize this type of device, and then you ask the network about what are the best parameters. The network will explore for you the space of solutions and will give you the best of that. And that works and saves time, again, at the cost of train that network and spend the computer and time resources for that. And this is real. I mean, you can fabricate these things. Here's just a picture of many of these devices. On the left side, we fabricate these devices. Actually, these were not made at AIM. These were made at Cornell nanotechnology facility. And here on the right, there's another example of one of our papers that we use AI for optimizing some quantum interactions. You can check all of that in the paper there in the reference. Now, let me go fast to the second example about how we can use AI for a signal recovery. In this case, we have a microring, which is just a ring of micron dimensions. And we want to use this for whatever application, but we turn out to have a signal which might be super noisy. So like the one here on top, right, with many weird things. So again, we can train a network and use the network to recover what is the actual signal we want to extract from that noisy background. And this is what we have here below with a clean signal using this technology. And the last example is about the design, the prediction I mentioned before, the prediction of materials with new properties. One of the easiest examples is probably, well, maybe not the easiest, but this is a good example, is to predict what type of materials we need to make an optical filter that transmits a color, red, blue, green, whatever. It's most of the times made by a multi-layer sequence of, let's say, most of the times a couple of different materials with two different indexes of refraction and with a nanometric thickness, probably less than 100 nanometers of thickness for each layer. So, if one wants to design a specific filter that transmits a specific color in the blue, green, there's a lot of methods to do that. But if you really want to do something a bit special, you may not be able to use those methods. And here, for example, we've been using this prediction to predict what could be the best filters for the UV, in the UV range from about 100 to 190 nanometers. It's a spectral region that has a lot of interest for space applications. So we designed a neural network where we train the network with these systems to predict what will be the spectrum. And then we ask the network to predict what will be the thicknesses if we want to have a specific transmission spectrum. So we can do this in both ways. We can do this in the forward way, where we tell the network, okay, here are the thicknesses, tell me what is the spectrum. And once we have that, we can ask about, I want this spectrum, tell me now what is the thicknesses of the layers I need. Okay, and that's where AI is super good for that type of prediction, and it's really accurate. Here you see how the green and the blue colors, the blue is the predicted, the orange is the actual response of the network. They typically match pretty well. Okay, so with this, I go to the conclusions. Yeah, as I said, AI is accelerating nanotechnology and obviously nanophotonics, especially in the prediction, measurement, and optimization. And I didn't mention much about the measurement. I want to signal to noise enhancement. But indeed, I know there are a lot of applications there where you want to test a specific wafer, and you don't want to test all the wafer because that takes a lot of time. So you just test some of the devices, and using AI, you can decide if your wafer is going to be used for a later process or not. So it's widely used, and I think it's going to continue to play a crucial role in nanotechnology and nanophotonics. And thank you very much.